Alright, let's look at another example of integration with u substitution. Let's say that I have the integral of 1 over x plus secant squared of pi x dx. Well, because I see I have addition here between these two terms, I know that I can break up my integral as 1 over x dx plus the integral of secant squared pi x dx. From here, we're going to evaluate these two integrals separately. I know that this first one, the integral of 1 over x dx, is equal to ln of x plus c1. But this other one over here, secant squared of pi x, isn't as nice. If it was just secant squared of x, I could say, oh, the integral of secant squared of x is simply tangent of x. But this pi combined with the x is kind of throwing that off, which is why we need u substitution. So if we let u equal pi x, then that means that its derivative du over dx is going to equal pi. Well, letting u equal pi x takes care of this part right here, but I also need to take care of this dx because now I'm in terms of u. So I want to get dx by itself. So I'm going to multiply both sides by dx and divide both sides by pi, which is going to get me du over pi equals dx. So now when I rewrite this integral, the integral of secant squared now of u, this is also going to be multiplied by du over pi. Alright, from here, let's rewrite our first part, ln of x plus c1. Now when I take this integral of secant squared of u times du over pi, this 1 over pi can come out in front as a constant. And then now we're just working with the integral of secant squared of u, which is simply tangent of u. And then because we're an indefinite integral, we need to add a constant at the end, call it c2. So from here, I don't want to leave my answer as this because I have one term in terms of x and the other one in terms of u. And I never really want to stick with something that I've substituted like this. So we need to go back up here to our u substitution and plug back in pi x for wherever we see u. So that's going to get me ln of x plus 1 over pi tangent of pi x. And then instead of writing plus c1 and plus c2, since these are both arbitrary constants, I can just, at the end, write plus c. And this is my final answer for the problem.